What if your computer could think not in ones or zeros, but in both at once? That's the promise of quantum computing, a technology that challenges everything we know about how machines compute, store, and solve problems. For decades, classical computers have been the backbone of our digital world. Every website you visit, every app you open, every photo you take, these are all processed by computers that use bits, the smallest unit of data, which can only exist in a state of 0 or 1. Their logic is binary, sequential, and very fast. But no matter how advanced they become, classical computers are bound by the limitations of binary processing. Quantum computers, on the other hand, play by an entirely different rulebook. Instead of bits, they use qubits, which can exist in a state of 0, 1, or both at the same time thanks to a quantum phenomenon called superposition. Add to that quantum entanglement, a mysterious link between qubits that allows them to be connected regardless of distance, and suddenly you have a machine that can process vast combinations of information simultaneously. This difference is more than technical, it's transformational. A classical computer might try every possible solution to a problem one at a time. A quantum computer can evaluate many potential outcomes at once, making it ideal for solving incredibly complex problems in cryptography, drug development, financial modeling, and climate simulation. But quantum computers aren't meant to replace classical ones. At least, not yet. They are better viewed as specialized tools, like a telescope compared to the human eye. Classical machines are still more efficient and cost-effective for everyday tasks like browsing the web or running office software. Quantum systems, however, shine when traditional machines falter, when problems grow exponentially with each added variable. Today's quantum computers are still in their infancy. They are sensitive to environmental noise, error-prone, and extremely difficult to scale. But as companies like IBM, Google, and emerging startups continue to refine the technology, hybrid systems where quantum and classical computers work together are emerging as the new frontier. Understanding the distinction between classical and quantum computing isn't just for physicists or tech insiders anymore. As quantum applications begin to touch industries we all rely on, being informed means being prepared for a shift that may redefine how we interact with technology itself. Which potential application of quantum computing do you think will impact your world the most?